There are three hazard components: the hazard source, the initiating mechanism, and the target threat outcome. The hazard source is the actual hazard itself, the candle burning on the coffee table. Initiating mechanism is something to trigger the mishap sequence, like the 4-year-old who throws the ball across the room, who hits and knocks over the candle. The target, the threat, the outcome can also be thought of as the victim, the person or property, the victim of the mishap, in this case, burning down the house. In the example given in our Erickson text, we see that high voltage is the hazard source. Exposed contacts and touching the contacts are two initiating mechanisms. Electrocuted worker is the TTO, the victim of the mishap. Identifying the hazard is good. It's important. Generally, it's the most difficult thing. But we cannot stop there. How can we use the anatomy of a hazard to mitigate the risk of losing our worker? Hazard anatomy can be loosely thought of like a fire. Remember the three legs to the stool of a fire. A fire requires fuel, oxygen, and ignition. Remove any of the three and you don't have a fire. Remove any of the three hazard components and you don't have a mishap by that set of circumstances. And that's the catch. So long as you have an HS, a hazard source, you have a risk. As long as our candle is burning, there are many ways it can catch the house on fire. We can remove all the balls from the house and even remove the 4-year-old, but there are still other ways in which the candle could get outside of its containment and spread through the house. In system safety, we must work through all possible IM scenarios and make sure that they are all considered. So let's go back to our example in the text. How do we mitigate the risk of our electrocuted electrical worker? Let's look at the hazard triangle. Two of the legs of the triangle relate to severity of the mishap, while the third relates to the probability. In our electrocuted worker scenario, if we reduce the amount of current or reduce the hazard source, if the worker touched the exposed contacts, there may be less damage than death to our worker. Reduce the severity. However, that is probably not realistic because we need a certain level of voltage to power our system. So we cannot reduce the HS, the hazard source, to reduce the severity of the hazard. How about the TTO leg? Remove the worker. Let's remove the worker from the system and then we wouldn't have as high a risk. Prohibit workers from working around the exposed contacts. We remove the TTO. Remove the victim, remove the outcome, remove the exposure. We still have the hazard, but no potential victim of the hazard. Mishap risk is eliminated. However, that is probably not realistic because we need the electrical worker to fix the system. So if we have the worker wear protective gloves, be ungrounded with leather boots and working in proper equipment, perhaps put guards around the exposed contacts, we have reduced then the probability of the mishap. We've reduced the probability that the worker will accidentally touch the exposed contacts. The electricity is still there, and the mishap victim is still in proximity, but we have reduced the risk due to reducing the probability of the worker touching the lethal exposed points. Here's another depiction of how the three hazard components must line up to allow a mishap. The hazard source and the initiating mechanism and the victim are all in the same proximity, same time. And so one of the illustrations how hazard can line up and result in a mishap, similar to the Swiss cheese model that you've probably seen. And that's the tip of the iceberg with regard to hazard anatomy. Under the hazard components, as we drill down to root causes, we find hazard causal factors. These hazard causal factors are specific items that are responsible for the existence of a hazard in the system. In our worker's example, we have a human. And we have energy, the voltage. The human must interface with the energy in order to do his job. The hazard goes even deeper to a level of specific causes. What causes the hazard to result in a mishap at a deeper level? Well, the worker has proximity to the exposed contacts. There is exposure in the exposed contacts. Personal protection, worn or lack thereof. Did a human err in accidentally touching the exposed points? And finally, then, we look at probability in a greater detail. The probability of a hazard is either 1 or 0. It's either there or it's not. The probability of a mishap is much more involved. It takes much more to decipher, and it involves the potential for each of the hazard source and IM, initiating mechanism, hazard components. The hazard is a propane tank in a barbecue unit. Leaks propane, which is ignited, causing fire, resulting in injury. The propane is there. It's a factor of 1.0. The IM components, though, propane leaks, burner is on, tank close to the burner, operator close to the grill. All of those other factors have their own probability factors, and those are all greater than 0, but less than 1. 1 is certain, 0 is unexistent. So the other factors are between 0 and 1. The product of all of those combined will give us the overall probability of a mishap. We're going to get into more of that quantitative detail in Unit 3. But in the next video, we'll talk more about reducing hazards and the hazard reduction order of precedence.